Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Quick housekeeping. Check out the affiliate links in our description. Using them supports the show, and please don't forget to rate, review, and share if you like what you hear. Let's jump right in. Today, we will be looking into Meta's new Llama 4 release. This is their latest family of large language models, and it marks a pretty significant step for them, especially since it's their first time using a mixture of experts architecture and building multimodality right in from the start. There are 3 models in this new lineup. First is Llama 4 Scout, designed for efficiency. It can run on a single NVIDIA H100 chip and handles a massive 10 million token context window. It uses that mixture of experts set up with 16 experts, activating about 17 billion parameters out of 109 billion total. Think of it like having a team of specialists, but only calling on the 2 most relevant ones for each specific task, making it faster. Then there's Llama 4 Maverick, geared towards more complex reasoning, coding, and handling different types of media. It also activates 17 billion parameters but draws from a much larger pool of 128 experts, totaling around 400 billion parameters. Finally, there's Llama 4 Behemoth, which is still in training. This one's the giant, with nearly 2 trillion total parameters and 288 billion active ones. Meta plans to use Behemoth as a kind of teacher model to help train future AI. A big deal across all these models is their native multimodality. They're built from the ground up to understand text, images, and even video together. Meta calls this an early fusion design, meaning inputs from different senses get combined right away into one unified understanding, instead of being processed separately and stitched together later. This should make them much better at tasks involving mixed media. The mixture of experts, or MOE, architecture is another key change. Instead of using the whole brain for every thought, MOE models activate only the most relevant parts, or experts, for the job at hand. This makes them much more efficient to run, allowing for these huge total parameter counts like Maverick's 400 billion, while keeping the active processing relatively lean at 17 billion. Meta also highlighted some advanced training techniques using over 30 trillion tokens of data, double Llama 3's amount, including text, images, and video across 200 languages. So how do they perform? Meta's benchmarks look impressive. They report Scout beats models like Google's Gemma 3 and Mistral 3.1. The experimental chat version of Maverick also scored well on the LM Arena leaderboard. And the upcoming Behemoth is claimed to outperform heavyweights like GPT 4.5 and Claude 3.7 Sonnet on certain math and science benchmarks. However, the real-world feedback from the community has been quite mixed. Some developers, especially on forums like Reddit, have expressed disappointment. One user noted Maverick's coding performance felt similar to much smaller models. Others found issues with instruction following or felt it lacked the spark of previous models. It highlights that benchmark scores don't always tell the whole story about practical usability. In the past 24 hours, community feedback continues to reflect a sharply divided perspective. On platforms like Reddit and X, developers and users have raised fresh concerns over Maverick's practical usability, particularly highlighting ongoing challenges with its coding and reasoning capabilities. One prominent thread on Reddit emphasized ongoing frustration, with users sharing examples of basic errors and unexpected repetitions, further fueling skepticism about Maverick's real-world effectiveness compared to competitor models like DeepSeek V3 and OpenAI GPT-4o. Some developers even reported abandoning Maverick for smaller, more consistent models, questioning the benefit of Maverick's large parameter count when the performance feels indistinguishable or worse than simpler alternatives. Conversely, there has been notable positive feedback regarding the Scout model's multimodal capabilities, and particularly its extensive 10 million token context window. Developers working on document-heavy applications, like complex data summarization and detailed research analysis, expressed enthusiasm, stating that the Scout variant significantly streamlined their workflows despite concerns about computational resource requirements. Licensing discussions also heated up recently, as more European developers publicly expressed frustration about being restricted from accessing the models due to regional compliance issues. These developers are now actively discussing alternative models or distilled versions they hope Meta might release soon. Meta's recent acknowledgement of these issues in an official post, promising imminent patches and performance enhancements in upcoming updates, has drawn cautious optimism from some corners of the developer community. However, many remain skeptical, choosing to reserve judgment until tangible improvements appear in upcoming releases, or until the LlamaCon conference addresses these specific performance and licensing concerns. Let's quickly recap the good and the not so good. Key advantages are the efficiency from MOE, that massive 10 million token context window on Scout, which is great for processing huge documents or codebases, the built-in multimodality, and the fact that Scout and Maverick are open weight, meaning developers can download and run them themselves. Meta's CEO Mark Zuckerberg stressed their goal is to build the world's leading AI, open source it, and make it universally accessible. But there are downsides. The real-world performance concerns we mentioned, especially in coding, are significant. The license, while open weight, isn't truly open source according to the Open Source Initiative, as it restricts use by very large companies and notably bars use by anyone in the EU, likely due to regulations. Some experts also question if the full 10 million token context is truly effective beyond 256,000 tokens due to training limitations. Meta themselves say they are working to enhance responsiveness and ensure helpful, factual answers without bias. The scale of Meta's ambition is clear, though, with plans to invest up to $65 billion in AI infrastructure in 2025. So, Meta's Llama 4 represents a major push with its new architecture and multimodal focus. While benchmark performance is strong, community feedback highlights areas for improvement, showing the complexities of translating raw power into consistent real-world utility. Overall, it's exciting to see Meta continue to push open models forward, aiming to make powerful AI more accessible, even with the licensing caveats and ongoing development needs. Thank you for listening to AI Convo Cast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.